Okay, so we're starting college algebra, and what I want to review real quickly is something you've seen back in your intermediate algebra days, distance between 2 points. Okay, so I'm going to kind of lead you by the hand a little bit, and it should be familiar territory. If you have a question, please ask. So, you folks are familiar with your Cartesian coordinate system. Usually we plot x that way and y this way. This is the input. This is the output value. Fancy words, old-fashioned words, are abscissa and ordinate. So, if I wanted to place a point that was at -2, 5, which quadrant would we put it in? We have 4 quadrants here. First, second, third, fourth. What did I say? -2, 5. -2 comes first, go to the left 2, and then up 5. Now, if I say that this distance to here is -2, then I've sort of established a scaling on this x-axis, haven't I? And then if I'm going to go 5, I could use the same scaling, or I could use some different scaling on the y-axis. So let me go ahead and just for convenience use the same. 1, 2, same spacing there. 3, 4, 5. -2, 5, placed in the second quadrant. Third quadrant's down here, and fourth quadrant's down here, and first quadrant's back over there. Okay, feeling good. Very basic beginning algebra level. Let's put another point. Let's say out over here. Why don't we make it interesting? Why don't we put it down in here in the fourth quadrant? So somebody give me some coordinate that looks like it would fit on what I've drawn here, down here in the fourth. 4, -2, okay? 1, 2, 3, 4, down 2. 4, -2. Okay. Now, what I'm interested in is let's do a couple of basic algebra things that are familiar to you. I'm interested in what the vertical spacing is between these 2 points. The vertical, in other words, the y distance between the points. What is that? Everybody see that? 7? And so what we're doing here is we are looking vertically like this. This point, think of this as maybe sea level. Then we're seeing 5 above the sea level and then 2 below the sea level. So the vertical spread there is 7. Okay. What's the horizontal spread between the 2 points? Now, I'm glad it's not 7 also. Okay. Not a very good example then. But it looks like it's 6, doesn't it? 4 to the right and 2 to the left. So the overall distance there is 6. Notice a couple of things. I have labeled the point. I'm trying to be a good role model for you. So when you do your homework, you'll do it the way you're seeing me illustrate it here in class. So I label the points. I try to do it relatively neatly. And if I can do it on a plain white board with no scaling, you should be able to do it on graph paper, which is what I want all your homework to be done on graph paper. Okay. If you can draw a picture, I want you to draw a picture. You're going to gain a whole lot of insight, and you're going to make a lot less mistakes if you will take that to heart and draw a picture every time you possibly can as you go through math or applying this math to other subject areas. I label the first point, I label this point, I look at the vertical spread, I look at the horizontal spread, and the question is, what's the distance between these points? Now, there was a fellow Pythagoras that lived a long, long time ago, and you probably all know something related to a right triangle. If you have a triangle with a 90-degree angle in it, it's called a right triangle. We have a leg here, a leg over here, and another leg, a hypotenuse right there. If you build a box, a square box on each of those sides, whoops, I'm going to run off the screen up there. up in there. And then we do the same thing down here, square boxes off of those. And we label this, traditionally you like to see it as what letters? A, B, C. And that's, all the textbooks do it that way. I'll do it that way today. A, B on the legs, C on the hypotenuse. And then this thing over here has an area of A squared. Similarly up here, an area of B squared, and down here, an area of C squared. You folks all remember that, don't you? That relationship. A squared plus B squared, those two smaller areas equal the hypotenuse being squared. Okay. Now that thing that you remember from actually pre-algebra, I hope, applies over here to tell us the distance between these points. So the distance between these points, I'm going to label it as D. And so we know then, by looking at my little sketch here, I have 7 squared plus 6 squared has to equal the distance D squared. Everybody feeling real comfortable? Okay. So we have 49 plus 36 is equal to the square of the hypotenuse. And so what do we get there? 70, 85 equals D squared. So without touching your calculator, what would be the answer for D? Square root of 85, right? So D is then going to be equal to the square root of 85. Now, does that clean up at all? Don't think so, because 85 is divisible by what? 5 for sure, right? So if you're playing with that, we know that 5 is divisible in there, so 5 times 17, is that right? 5 goes into 8 once, leaving a remainder of 35. 5 into 35, 7. So we pick up the 5 times 17. Both those numbers are prime, aren't they? So we cannot simplify this. This answer is exact. And you'll notice that I use a precise equal sign right there. Okay. Here's another habit I hope I can get you to do. Besides drawing, labeling points, and always sketching, if you have a precise answer, use the equal sign. Now you know with your brain that this answer is going to be more like, it's going to be about what? A little bigger than 9, right? So you could write down 9 with a little positive sign like that before you ever touch your calculator. Okay. And if you then punch your calculator and get something that isn't a little bit bigger than 9, you know something's wrong. So always try to use your brain before you turn that darn calculator on. Okay. Okay. Always use your brain first, please. Okay. So we're going to get an answer a little bigger than 9. That should feel right. If you look at a sketch that you've drawn, you should be able to look at that and go, oh yeah, let's see, if that's 7, yeah, that looks like it's probably 9 or a little bigger than 9, something like that. So your sketch should fit with your algebra, and then when you punch it on a calculator, that all should tie together. That combination of sketch